Welcome to the Energy Comedy Club, where physics gets a comedic twist. If you've ever wondered why your little brother running around is more annoying than a sleeping cat, the answer is kinetic energy. Kinetic energy is simply the energy of movement. If something's moving, it's got kinetic energy. Whether it's your teacher walking toward you with a surprise quiz or you trying to escape, both are examples of kinetic energy in action. Faster something moves, the more kinetic energy it has, and if you double the speed, you quadruple the energy. That's why your mom tells you to slow down on your bike. She's just applying physics. Let's dive into the two main types, translational and internal kinetic energy, and see how they shape our everyday lives. Translational kinetic energy is all about the whole object moving from one place to another. Imagine kicking a soccer ball across the field. The entire ball is flying through the air, demonstrating translational kinetic energy. Or think about the school bus carrying students each morning, or you sprinting down the hallway when you're late for class. Even the pizza delivery guy racing to bring you dinner is a perfect example. Math behind it is straightforward. Ke equals 1/2 times mass times velocity squared. So if your 60 kg friend runs at 5 meters per second, they have 750 joules of kinetic energy. Whenever you see something moving as a whole, you're witnessing translational kinetic energy in action. Now let's peek inside objects for internal kinetic energy, the energy of particles jiggling around inside. Even if something looks calm, like a water bottle on your desk, its molecules are bouncing and vibrating like they're at a rock concert. The hotter something is, the more intense this molecular party becomes. For example, a cup of hot chocolate isn't moving, but its molecules are zooming around, creating internal kinetic energy. A pot of boiling water or your phone heating up during gaming are other great examples. Even an ice cube has internal kinetic energy, though its molecules move slowly. Temperature is just a measure of this internal energy. Hotter means more movement, colder means less. Let's compare these two types of kinetic energy. Translational kinetic energy is about the whole object moving, like a baseball flying through the air. Internal kinetic energy is about the tiny particles inside an object moving, which you can't see without special equipment. Translational Ke uses the simple formula half mv2, while internal Ke depends on temperature and is much more complex. In real life, these energies often interact. For example, when you drop your phone, its translational Ke turns into internal Ke, heat and vibrations on impact. Or when you slide across the floor in socks, friction turns your movement into heat. Energy never disappears, it just changes forms, making physics both fascinating and practical. Understanding translational and internal kinetic energy helps explain so much about the world. It's why brakes get hot when you stop a car, why rubbing your hands together warms them, and why perpetual motion machines can't work. Energy always converts to less useful forms like heat. Even when you leave a window open in winter, internal kinetic energy escapes, making your room cold. Remember, energy doesn't disappear, it just transforms. So next time you feel full of energy, science literally agrees with you. Whether you're moving or just sitting still, you're a bundle of kinetic energy in action. Keep this in mind and you'll ace your next physics test, or at least understand why your socks get warm after sliding across the floor.